All right, let's talk about a technology that is quietly becoming the absolute backbone of agentic AI. It's called the Model Context Protocol, or MCP. And this isn't just some minor update, it's a critical open standard that is literally changing the game for how AI systems break out of their digital boxes and start interacting with the real world. We're going to break down exactly what it is and how it works.
So, here's what we're going to cover. First, we'll dig into why AI is fundamentally stuck in a bubble. Then we'll introduce MCP as the universal connector that pops that bubble. After that, we'll get into the technical nitty-gritty of its architecture, see why it's such a massive leap past basic function calling, and finally, we'll look at some powerful real-world examples and talk about the incredible agentic future this is all leading to.
Okay, so before we can really appreciate just how cool MCP is, we've got to understand the fundamental problem it was built to solve in the first place.
The core problem is pretty simple, really. For all their amazing capabilities, large language models operate in almost complete isolation. I mean, think about it. They're trained on a static snapshot of the internet. They have no way, right out of the box, to access live data, use external tools, or interact with any of your private systems. They are, for all intents and purposes, brilliant minds trapped in a jar.
And this isolation leads to a massive headache that developers call the N by M integration problem. Basically, for every N AI models you have and every M tools or data sources you want them to connect to, you have to write a totally custom, one-off piece of code. It just creates this tangled, brittle web of bespoke integrations that is a nightmare to maintain and completely unscalable. It's a huge engineering drag that just kills innovation.
So that's the mess. Now, let's get to the really cool part, the elegant solution that cuts through all that chaos. Let's talk about the Model Context Protocol.
So what is MCP really? Well, at its heart, it's an open standard that acts like a universal translator for AI. It provides one single standardized way for any LLM application to talk to any external tool or data source. And when you have that, you can just toss out all that custom integration work. No more one-off connectors.
And this is why it's such a big deal. People in the know are calling this thing function calling 2.0. And that's not just hype. It's not just a small step forward, it's a whole paradigm shift away from the first generation of AI tool use. We're moving from just simple fire and forget commands to these rich, ongoing conversations with tools.
Honestly, the best analogy to make this click is to think of MCP as the USB-C port for AI, right? Just like USB-C finally gave us one standard plug for all our devices, MCP is giving us one standard digital connection for all our AIs. You build your tool with an MCP interface just once, and boom, any AI that speaks MCP can use it instantly. It's that simple.
Okay, so how does this magic actually work under the hood? Let's peel back the layers and look at the technical architecture, which really just comes down to three key components.
First up, you've got the host. This is your main AI app, the one the user is actually talking to. Think of a coding assistant inside your IDE, or a really smart chatbot. The host is the brain of the whole operation. It's the conductor of the orchestra.
Now, running inside that host is the client. For every single external tool the AI needs to talk to, the host fires up a dedicated client. This little component's only job is to manage the communication channel to one specific MCP server. And that client connects to a server. The MCP server is basically a wrapper that sits around an external system. It could be a database, a corporate API, even your own local files, and it exposes that system's functions to the AI using the standard MCP language. This is the AI's gateway to the outside world.
The server exposes its capabilities using three fundamental building blocks, or what the protocol calls primitives. The first one is tools. These are exactly what they sound like. Executable functions the AI can call to actually do things. Things that can have side effects, like sending an email or running a database query.
Next up, we have resources. These are your read-only data sources. They're how an AI can query for information and get context. Now, you might be thinking, hey, that sounds a lot like retrieval augmented generation, or RAG, and you'd be totally right. But the critical difference here is that it's all done through a standard interface, making any data source kind of plug and play.
And the third and final primitive is prompts. Now this one is really clever. These are reusable templates or hints that the server can give back to the AI. So, for example, a database server might offer up a perfect prompt template for building a complex SQL query, essentially teaching the AI how to use it better. And maybe the best part of all this? The whole thing is built on rock-solid, familiar standards. All the communication happens using JSON RPC 2.0 messages. And the protocol is transport agnostic, which is just a fancy way of saying it doesn't care how the data gets there. It can run over your local standard I/O for a tool on your machine, or over HTTP for a cloud service. Total flexibility.
So it's this clever architecture that allows MCP to be a genuine game changer compared to the old way of doing things, what we call traditional LLM function calling. Let's really dig into the difference.
The single biggest difference boils down to one word: state. Traditional function calling? It's totally stateless. The AI makes a one-shot request, it gets a response, and that's it. The interaction is over. MCP, on the other hand, is all about establishing persistent, stateful sessions. It's not a single transaction, it's an actual, ongoing, two-way conversation between the AI and the tool.
So let's really break down these advantages. With MCP, the server actually remembers what's going on in the conversation, so the AI doesn't have to keep resending all the context with every single call. The communication isn't just a one-way street anymore either. The server can actually push notifications to the AI. And all of this together unlocks these really complex, multi-step agentic workflows that were just impossible before. And maybe most importantly, it's all built on an open standard, not a dozen different proprietary APIs.
Okay, theory is great, but let's see how this actually plays out in the real world. Let's look at some use cases where this really shines.
So check this out. Imagine a user asks their AI, hey, create a summary of all the critical payment tickets from last month. What happens? First, the AI connects to a help desk MC server. Then, it starts using the search tickets resource, probably paging through the results bit by bit to find all the right tickets. Now here's the magic. The server holds onto that list of found tickets in the session state. This is huge because it means the AI doesn't have to cram everything into its own limited context window. Finally, once it has all the tickets, it calls the create report tool, which uses that context living on the server to generate the final summary. This whole back and forth state-aware process, absolutely impossible with plain old function calling.
And you see this powerful pattern everywhere. In big companies, it's being used for secure search across internal wikis like Confluence or Google Drive. For developers, it's a dream come true, giving an AI assistant the real ability to use Git, read and write files, and even kick off CI/CD pipelines. And of course, this is the bedrock for building truly autonomous agents that can do multi-step research, planning, and then actually execute on those plans.
And that really brings us to the big picture here. Because MCP isn't just a slightly better way to call an API. It's the foundational layer for the entire next wave of agentic AI.
So that leaves us with this really exciting, provocative question. If MCP is basically becoming the HTTP for AI, the universal protocol for interaction, then what's going to be the first browser? What's the killer app? The Netscape Navigator or Google Chrome that's going to be built on top of this new agentic internet of tools? That is the future that MCP is unlocking right now.